Okay, so what we're going to be doing here is looking at functions. So this video will give you an introduction that you can use as you read up on the chapter. So let's start off thinking about what a function, why do we want to use functions? So one of the things that you run into as your programs get longer is that it becomes harder to understand them, harder to maintain them, and it's easy to make mistakes. It's also the case that they're harder to read. So the one solution is to chunk the program into smaller pieces. So each piece is smaller and it's easier to manipulate. Another reason is that sometimes you have to do the same operation multiple times in different parts of your program. So rather than writing out the code to do that operation 10 times, you just write a function and then you call that function 10 times. So if you had to write a function that computes the interest rate earned on your bank deposits, and you had to use that in several different parts of the program, you can imagine that might take 5 or 10 lines of code. And if you write one function that has 5 or 10 lines of code and then you call it each time, it's probably going to work a little better. If you think about a function, you can think about it in terms of how a car works. So cars have lots of parts, but if you think about the brakes, a car has lots of parts, right? And if you tried to lay out each part individually, it would be really hard to manage, to understand, and so on. So you can think of it more abstractly by thinking about the parts of the car that are related to the body, to the interior, to the brakes, and so on. So functions give us a similar way to think more abstractly about our programs. Once you've gone to the trouble of writing your function to create to calculate interest, then you can ignore the details and just know that I call that function to calculate interest. If you think about that from the perspective of brakes, also it gives us another reason. When brakes were originally created on cars, you pushed on the brake and it was like a rod that would push on something on the wheel itself that would slow the car down. And you would have a pedal that you pushed on. Now that has evolved over the years, so they got power brakes, power assisted brake, anti-lock brakes, which are much more sophisticated, but the interface to that function, the way that you access it, is still the same. You still push on the brake in your car to slow it down. So another reason that we use functions is that it allows us to improve something under the hood or extend it without having to change the calling program. It provides an abstraction barrier. So what is a function in JavaScript? So a function is an object that performs a specific calculation or a set of instructions. They take input data, like numbers, words, strings, other objects, and return output. Let's look at an example. So here's, for example, a function to compute the balance on your bank account after T years from a starting balance B and an annual percentage rate R with interest compounded n times per year. So if you took an accounting or a business class or even a math class at some point, you might recognize this as compound interest. It's how we make money on our savings accounts. Assuming that. Yeah. So if you think about a function to compound the interest on your bank account, it takes 4 inputs and provides 1 output. T is the number of years, B is the starting balance, R is the percentage rate, N is the number of times per year, and then it produces the value, which is your ending balance. So starting balance, years, percentage rate, number of times compounded, and then the ending balance. So from this perspective, a function provides us an abstraction so we can treat this as a black box. You don't need to know how it works to use it, you just need to know the result. Somebody needs to know how it works to program it, to code the function. But if you're just calling it, you don't necessarily need to know the details. Now, we've already been using functions, the math functions, the prompt, console.log, alert. So what we've been doing up until now is using existing functions. What we're going to talk about now is how you can start to create your own functions that allow you to build these larger programs. So the first thing to think about is, how do we define a function? How do you tell JavaScript, the JavaScript interpreter, that you're going to create one of these functions? So here's the general form of a function declaration, is that you use the keyword function, you give it the name that you're using, and then if there are any inputs, like the number of years or the starting balance for your compound interest function, you list those with comma separated, and then you put in the JavaScript code in the body of your function inside of the curly braces, open curly brace, close curly brace. And then if your function is going to return a value, like the ending balance, you use a return statement using the return keyword. So the terminology is important. I'll use this consistently. Functions are called by the calling program by using the name followed by the parenthesis operator. That tells JavaScript, the interpreter, that you're going to call that function. A function can receive values via the parameters in this. When you list the parameters, and I'll show this in an example, you don't use the var keyword. They're in a sense, they're pre-created for you. A function may return a value using a keyword, and there are other ways to define a function. Here's an example. To define a function to compute the cube of a number, so x times x times x. Here's a simple example. So we use the function keyword. We're going to name our function cube, and it takes one input value, just the value of x. So that we put the x inside of the parens. And then in the body of our function, we have two statements. Notice we have an open curly brace and a closing curly brace. And inside of them, we have defined a variable cubed number, and we've assigned it the value of x times x times x. So we're just cubing it. And then we return cubed number. So notice the return statement, the return keyword, followed by the value that we want to return to the caller, and the semicolon, of course, to end the statement. Let's see. So there's the name, there's the parameter, and there's the body. Now, how do we call it? Oh, and there's the return. Now, how do we call the function? Here's an example right here where we call the cube function with the value of 3, and we pass that result to the alert function so that it displays 9 to the user in an alert box. Another example, we can take the value returned by the cube function, cube of 3, and assign it using the equal statement to a new variable that we've just defined called cubed value, and that will assign the value of 9 to the value.